Demonstrate how to conduct a one sample proportion test. This information has all the steps to doing it. This is kind of what a one proportion test is about. Then there is one sample proportion hypothesis test and all the different steps. All the steps are always the same in every hypothesis test. And you have conditions, you have calculations, you have conclusion, and you have interpretation. This will actually show a very specific example for group work on this section. So according to the Auburn University website on honeybees, beekeepers across the United States lost 45.5% of their managed honeybee colonies from April 2020 to April 2021. According to the preliminary results of the 15th annual national survey conducted by the nonprofit Bee Informed Partnership, or BIP. Commercial honeybees operations are essential to agricultural production in the U.S., pollinating about $15 billion worth of food crop each year. Honeybees colonies are moved around the country to pollinate important agricultural crops such as almonds, blueberries, and apples. Minimizing their loss and ensuring the health of both commercial and backyard colonies is critical to food production and supply. In New Zealand, suppose a randomly selected beekeeper has 3,000 bee colonies. A beekeeper has 327 bee colonies that collapsed. At the 5% level, does this provide evidence to support that the population of bee colonies that collapsed in New Zealand is different from the proportion of bee colonies that collapsed in the United States? So this is a hypothesis test. Let's first state what our random variable is. So we are counting the number, the variable is the number of bee colonies that collapse. And we actually only care about in New Zealand. Our parameter is the proportion of bee colonies that collapse. Again, only in New Zealand. I'm going to go ahead and copy that because I'm probably going to need this again. I'd like to now state the hypotheses. So again, we have two hypotheses. We have our null hypothesis. HO. And we have our alternative hypothesis. HA. I usually start with the alternative hypothesis. This is my question. I want to know if it's different. I want to know if the proportion of bee colonies in New Zealand that collapse is different from the proportion of bee colonies that collapse in the US. So that's my question. My null hypothesis is always going to be the equal to. So it's not different, is the same as the proportion of bee colonies that collapse in the US. Now we want to state and check the conditions. So the first one is we're going to state that a random sample of we're looking at the health or the collapsing or not collapsing. So a random sample of bee colony status in New Zealand is taken. And we had, if I remember correctly, we had 3,000. So we'll put in a random sample of 3,000 bee colony status is taken. We're gonna now check this. And unfortunately, we have no idea because we don't know where these came from. We don't know where this information came from. Oh, I'm sorry, we do. It does say randomly selected. So this was stated in the problem. that a random sample was taken. Now we're going to state the next one, and what that is that the properties of a binomial experiment have been met. That's our stating. And then we'll check it. And the check is that there are 3,000 colonies. So it's a fixed number. There are two outcomes. Since they can either collapse or not collapse. And the next one is that they're independent. And that one I'm not so sure about because this is just one beekeeper's colonies. We don't know if one colony would affect another colony. So this one may not be true. But we're going to assume they are. And then the last one is that the probability is the same. Of collapsing. And is true. So the properties have been met. The last one is that the population proportion, sorry, the sampling distribution of the sample proportion can be approximated by a normal distribution. The check on this is to look at the sample size n times p, which is our proportion, and we have we know that in the United States that is the proportion was 45.5. So we're going to multiply that n of 3,000 times 45.5, 0.455. And we're also going to do n times q, which is going to be 3,000 times 1 minus 0.455. And all we have to do is just make sure that they're both bigger than 5. So I'm going to let R do this calculation for me. So I'm going to do 3,000 times that, and I'm going to do this other one. And I just need to make sure that both of them are over 5. Got a multiplication symbol there. There we go. And we get both those numbers are more than 5. So that does work out. So we can say this is true. Since the both numbers are more than 5. Okay. Calculations. We're going to quickly do our calculations. It is a prop dot test. We're going to put in, we had what our X value is, which is our measured value. So there were There were 327 that collapsed. Our N is 3,000. Our P is equal to 0.455. We are two-sided, so we don't actually need to put that in there. And it will calculate for us. So here's our answer. Our p-value is less than this number. Here's our test statistic value. We care about the p-value. So we can actually say, since that is much less than 5%, we can reject HO since the p-value is less than my alpha. And the interpretation of this would then for be, there is evidence that, and this is where you can just go grab your HA. Our HA in this case is right here, our alternative hypothesis. And we can just say that. So we can just plug it in there, that it is different, and we're done.